All right, number one, we have to decide, is this rational or irrational? Is this it's a square root, so is it a perfect square or is it not? Well, kind of your dead giveaway here is the squiggly equal sign, which means approximately. So this is not going to be rational. Square root of 79, we need to approximate what is this. Well, we know it's going to be in between the square root of 81 and the square root of 64, because this is 9. This is 8. 79 fits in between here. It's going to be closer to 9 than it is to 8. But go ahead and just use your calculator and give me a good estimate. Maybe like blank point, blank, blank. All right. So round to the nearest hundredths place. Number 2, 5 times 5 times 5. That's what that means, not 5 times 3. So do 5 times 5 times 5. Give me a final answer. Number 3, we need to estimate these for rational numbers. The square root of 10 is in between the square root of 9 and the square root of 16. It's in between 3 and 4. Okay, so, but it's also in between negative 3 and negative 4. So negative 3, negative 4. So we should have about, for the square root of 10 on our number line, we should have about 3.5 and negative 3.5. I realize, yeah, it is closer to 3 probably than 0.5, but that's going to be close enough for me in this section. Okay, so 3.5, negative 3.5. If you want, you can use your calculator and get a more precise number for these. Do the same thing for 21 and same thing for 15 because they're all irrational numbers. None of these are perfect squares. Number 4, 5, 2 to the 5th, 2 to the negative 3rd, 2 to the negative 4th. There is such a rule called the product of powers. And it says if you're multiplying more than one base number together, all you have to do is add your exponents together. So we're going to do 5 plus negative 3 plus negative 4. And so this will be negative 2, because 5 minus 3 is 2, minus 4 will be negative 2. So we get the answer 2 to the negative 2 power. We also have to get a positive exponent, so this is going to equal, with a negative exponent, here's what we do. We say 2 to the positive exponent and just put a 1 in the numerator. It's an inverse exponent, so we can flip it over and put it on the denominator of a fraction. 1 over 2 to the second power. 2 times 2, because there's 2 2's we need to multiply by, is 1/4, and that's our answer. Now to better explain this problem, we have 2 to the 5th in the numerator. With our negative exponent rule, we've got 2 negative exponents. So we can go ahead and put those in the denominator, 2 to the 3rd times 2 to the 4th. So what this looks like is 2 times 2 times 2 times 2 times 2, 5 of them in the numerator. We've got 7 on the denominator, 2 times 2 times 2 times 2 times 2 times 2 times 2. And we could start reducing these and canceling these off. 3, 4, 5. Canceled 5 of them off. This is also times 1, so we end up with 1 on the numerator and 4 on the denominator. Ooh, whoops. For the last one, we need to solve this scientific notation problem. Again, we have a negative exponent. So we're going to go ahead and take that, put it on the numerator. So we're going to end up with 1.85 times 10 to the second times 5.0 times 10 to the 8th. All right, so we've got 2 different positive exponents of 10. This is times 10 times 10. This is times 10 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 times blah, 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 right? So we have, if we combine these, we have times 10 to the 10th power. And then we're going to combine these two. So we're going to do 1.85 times 5, which will be less than 10, which is good. 1.85 times 5, we get 9.25 times 10 to the 10th power. And that's it.